Welcome back, Year Sevens. You've survived one lesson so far from home. So this is part two of goodness knows how many of our maths lessons. We're going to be doing some more fractions today. So what we're going to be learning, here's our learning intention, is the main thing you've got to do from this lesson is know how to turn an improper fraction into a mixed number. So to be successful at that, to get it right, the two things you'll have to be able to do, our success criteria one, is to be aware of what a mixed number actually is, and also to be equally aware of what an improper fraction is. If you don't know what an improper fraction is, and you don't know what a mixed number is, it's going to be very, very hard for you guys to turn improper fractions into mixed numbers. Once you've been reminded of what they are, or you know what they look like, we can then use our division skills to divide the top by the bottom of a fraction and turn an improper fraction into a mixed number for reasons. Okay, it's time to start being successful. Let's figure out what the difference is between these different types of fractions, proper, improper, and mixed. We're going to drag these fractions from along the bottom and put them up here. Usually I've got like a noisy Year 7 boy on my left who'd be doing it for me, but I'll have to just drag them in the right spot for you. So to know the difference between these three things, proper, improper, and mixed, you should just think about the actual English words. If you know your English and you know your words, the maths will soon follow pretty closely behind. So to be proper is to be correct. My head is not as big as my belly, I guess is one way of thinking about it. It's the proper way to be. If my head was bigger than my belly, then I'd be improper. Uh, to be proper when you're a fraction as well is to be less than a whole thing, because a fraction is part of a whole. So all we're looking for is for the number on top to be smaller than the number on the bottom, so I don't have more than a whole thing. So 2/9 is a nice little fraction. I've got something that got cut into 9 pieces and I get to keep 2 of them. That's a proper fraction, and you're probably noticing that the other one down here is 1/3. That one is also a proper fraction. To be improper is to have a head bigger than your belly, or to be bigger on top than you are on the bottom. So 4/3 is more than a whole thing, but it's written improperly, and so is 6/5. And then to be mixed is to just have a combination of things. So this mixed fraction here, this mixed number has a whole number, a 3, and 1/8 to go with it. So that's the difference between proper, improper, and mixed. Now we can start converting them. All right, so what we're going to be getting into today is being able to change between these mixed and improper fractions. First go one way, then the other, because what we need to understand is that this value here, where I've got 1 whole and 1/2, and this fraction here, this improper fraction, where I've got 3/2, they are the same thing, they are the same amount, but we need to be able to convert between one and the other, so we can actually do maths with them. When do we bother doing it? It's mainly because you're going to spend a lot of time this term multiplying, dividing, adding, subtracting fractions together, and some fractions are just easier to work with, or some types of fractions are easier to work with than others. You'll figure this out later on, but having to do something like this, like 3 wholes and 3/8, and times this by, I don't know, 4 wholes and 2/6, is much, much, much more complicated than going 27 lots of 8 times 26 lots of 6. One of these is really, really hard, and we don't want to do it, and the other one is a bit more convenient for us. So we need to convert these fractions first before we can actually do maths with them. All right, so what we're going to be encouraging you to do all the time as we work through this unit of work on fractions is to really think carefully about what a fraction actually is and what it represents. They're not abstract ideas, they actually represent something. So when I give you a fraction like this, 7/4, it means something. What it means is I'm getting something that's cut into 4 pieces. So I've started with something, some object, some idea, some amount, maybe with money, and I'm chopping that thing up into 4 pieces. But in this case, I've got 7 of those things. So if we want to visualize what that means, it'd be like cutting someone's picture right into quarters and having 7 of them. And then what we're going to make you think about today is if I have 7/4 of something, how many whole amounts of something do I have, and then what's left over? So with these 7/4 I've got, I could try and put my quarters together to try and make something whole. This one goes here, this one goes there, a bit of a jigsaw puzzle. So I've put one of my wholes together. I took my 4/4 and I made a whole out of it. But then I've got these 3 other pieces left over. Okay, so what that means is I've got 1 whole and I've got 3/4, and that's going to be the mixed number that will come out of this. Maybe it'll make more sense if we look at something more sensible like pizza. Pizzas can be cut into 4 pieces, if I eat 7 quarters of a pizza, which I have done before, that means I've eaten more than a whole pizza. Okay, my first 4 quarters encompassed this first pizza, then I've got 3 quarters left over. So essentially the answer to this question, if the question was, what is this as a mixed number? I have 1 whole and I have 3 quarters left over. Okay, and 1 whole and 3 quarters, you can see, is the same thing as 7 quarters. All right, so I do know that a lot of you out there don't like thinking or conceptualization or anything like that. So what we do have for you here is the slide that we normally give you guys to put in your glossary. So if you want to write this down with these worked examples and put them in your glossary, it'll help you if we ever get around to doing a test on this stuff. I still think it's really good to just think about the concept of the fraction. This question here is about quarters. It's about things that are cut into 4 pieces. So really just ask yourself the question, if I played 18 quarters of football, how many whole games did I play? And, how many other quarters of a not full game did I play? Uh, if you can answer that question, you can write it down and you're done. But if not, you can follow these steps, okay? So this is really a division question because fractions, we don't like to tell you guys this, but fractions are really just divided bys. We're going to divide the top by the bottom. We're going to divide the numerator by the denominator. So you can just picture it like this if you want, right? We're putting 4 into 18. All right, we know that 4 goes into 18 4 whole times, right? 4, 8, 12, 16, and then we can't fit 4s into 18 anymore. We got up to 16 though. We didn't get to 18, which means we had 2 left over, 4 remainder 2. How that goes then for this fraction is I do have 4 whole numbers, right? 4 went into 18 4 whole times, and then I had remainder 2 left over, which means I've got 2 quarters left over. If you're being extra special and going above and beyond, you could write that as 4.5, but we're happy for you to leave it like that at the moment. So applying that then to this question about fifths, if I've got 43 fifths, so I've chopped all my things up into 5 pieces each, and I've got 43 pieces. How many whole things did I actually chop up? So we're going 43 divided by 5. So 5 goes into 43 8 whole times, right? 5, 10, 15, 20, 25, 30, 35, 40, right? 5 times 8 is 40. So it goes in 8 whole times, but I only got up to 40. I didn't get to 43. So I've got 3/5 left over. And that is how you convert your improper fraction into a mixed number, and you'll have some work to do on that on your Google Classroom.